you are given an array of integer that is called a stone, and another we have is a stone of I is the weight of ith stone, you can say. Okay, and we are playing a game with the stone. On each turn we choose the heaviest two stones and smash them between together, and suppose the heaviest two stone have weight across x and y. X should be less than equal to y, and the result of the smash is if x equal to y, both are destroyed. If x not equal to y, stone of weight x is destroyed, and stone of y has a new weight y minus x. Okay, at the end of the game there is at most one stone, right, and it is left. Okay, so we have to return the weight of the remaining stone. If there are no stone left, we will return 0. Okay, so let's understand stone. Okay, so first stone we have given is to what we have given, 2 7 4 1 8 1. Okay, this is the thing we have given in the stone form. Okay, so what we will do, if we'll represent this into array, it will look like this one. Okay, so it is saying that first of all what we have to do, if we will choose two stone. Okay, so and then we'll smash them, right? So what is we will combine, it is saying, let's see the explanation. It's saying we combine 7 and 8, right? What will happen, we have 7 and 8, and to get 1, so array will convert into this one, right? 2 4 1 1 1, right, like this. So if we will selecting 7 and 8, right, so after this one, because if x is less than y, right, suppose the heaviest two stone have weight x and y, and x is less than y, right, less than equal to, that is true, right, in 7 and 8. So in this case it is not equal to, means in the y minus x we have to do. So 8 minus 1 will do, 8 minus 7 will do, it is equal to 1. After this what will happen, this array will get converted into 2 1, and 2 4 1. Then what we have, 8 minus 7 is 1, and this last one is 1, right? So this array will become like this. So if we'll represent this one into array, it will look like this one. After this we will select 2 and 4, right? So after selecting 2 and 4 we will get 2, right? So what will happen, we'll have 2 1 1 1, right, like this we will get the array. Similarly we'll select 2 and 1, so we'll get what, 1 1 1 1, right, like this we'll get after smashing this one. Sorry, we are selecting in this case. Now we have 1 and 1, so after doing 1 1 1, right, what we will get, we'll get 0, right? And if we'll do convert this one, we are selecting these 2, right, so we'll get what, we'll get after this smash, we are not going to smash, we'll get only 1 in the array, right, element, because see, if both are equal, then we are doing destroyed, right? So after they're destroyed, what will happen, there is only one element will remain. That's the value of the last stone, that we can say this is the last stone, 1 remaining, right, after smashing of these 2. Okay, I think got it the question. Okay, so in this way we will return output. So if there is only one stone into the you can say stones, right, we will return only one, because at least 2 elements should be there, right? So this is the last element, so we will return the last stone value is 1. And let's understand the implementation part, right? So now you understand that we how to return, you can say, the last stone, right? So now we are here at the coding section, right? So conceptually the simplest way we could solve this problem is by doing the search for the 2 largest stone in the array, and we'll delete them, and after that, then if they are not the same size, add the new stone size back to n, and we can repeat this process until there is only one stone left, right? Because the array is not sorted, there is no need to preserve the original order. Removals should be done by swapping the last value, not by the shuffling all values along. Okay, so how we'll do that, let's understand here. Okay, so first of all we should have 2 things. we have given a stone, as you can see here. What we have given, this stone we have given in the array, right? So let's go and we'll do what, we'll move on the stone, and we'll take, better we'll do, we'll create one list, right? And this list will contain, you can say integer like this. So this list will contain, with this list we can say stone list, we can say, right? A stone list like this, right? A stone list, and this stone list will become what, new array and list like this. Okay, after this what will happen, we'll move to all the stone, right? We have a stone, at a time we'll get one of the weight, right? Integer, and this is called stone weight, WIGST weight. So we have made a loop over the stones, so one by one stone will get, and we'll get all the weight. So we know that we have a stones, right, list. So on the stone list we'll add this one, you can say the weight, right? And this is our weight we have. So each time we'll add here, right? So all the weight of the stone is added onto the stone list, right? As you can see here, we are adding here. Okay, now after adding all the stone, right, all the weight on the stone list, now we have our list maintained, right? From there, on the maintaining list, right, what we will do, we have a stone list, this one. After do, we'll get the size, right? This one. So the size will give you its size, and if the size is greater than what, 1, right, at least one element will be there, right? So if because constant is saying, okay, so if you can say the stone list dot size is greater than 1, in this case what will happen, we will create one you can say remove function, right? And we'll remove 2 stone. How will do that? Let's suppose we have this is our stone 1, we can say a stone 1. Okay, so this stone 1 will get from something, we can say the larger one, right? So if we will remove larger one, remove larger stone, right? Remove larger stone. Okay, how we'll do that? This is our function, and this will we will pass our stone list. Okay, this list will pass and we'll get the larger stone. Okay, based on this function. We'll develop this function later. First we'll understand this one. Okay, similarly what we'll do, we'll get one more stone, right? List 1 and stone 1 and stone 2. So after removing this one, we have the second largest stone from here. This is the largest stone x, y, you can say y, and this is your largest stone x. Okay, so you have both stone x and y, y and x we have, right? Now we know that what we have to do, we will check if it is not equal to, right? If it is equal to, it will break, correct? So you have what, we have stone, you have stone 1. If stone 1 is equal to, or you can say not equal to also say, if not equal to, sorry, stone 2, if it is not equal to, if equal to, it will break, right? And if not equal to, it means what, we have to do minus, remove. So we have the stone list already, right? We have our stone list. On this we have to add actually, right? What we have to add, we will do minus a stone 1, right? This is our stone 1 minus a stone 2 will do, and we'll add on to the our stone list. Okay, right? And if it is equal to, we are destroying this one. Okay, now what we have, this function will do its job. After that we will return what, if not stone list. If a stone list we have, let's suppose this, and is empty, suppose is, if it is not empty, if it is not empty, and stone list and a stone list dot will do remove, there is a remove function, and will pass its index. If it is not empty, we will remove, right, or we'll add 0. If not empty, we'll do remove, we will remove and we'll put 0, right. If not, actually if it is empty, we'll return 0. So now only one thing remaining is creating this function. This function will take what, stone list, right, and it will return a integer value to, because we are storing here. Okay, to do that, let me zoom out a little bit. Okay, I'll create one function here. I'll give the int this function, and we have to give the body, right. So this function will return something called let's suppose this is called result. Okay, so this result is nothing but its largest value. Okay, remove larger value. Okay, so you can say larger result or whatever you can say. Okay, so this stone is, we know that this is nothing but our this one, got it, this one. Now what we have to do, now we know that we have our stone, right. This is the stone, we have a stone list, right, or you can say this stone. From this stone, what we'll do, we'll check the index of largest, right. To find the index of largest, what we have to do, we can give the name of index of largest. How we'll get this one, index of largest stone? We can get from what, we have a stone list. From the stone list we'll do index of, and we'll we can find, you can say there is a function in the collection, right. You can do collections. This is the collection framework, right, in the Java. This function give you to find your maximum element from the list. How we'll do that, collections dot max, and we have to find our stone list, right. Why it is not going, yeah, stone list. Okay, so you will get our index. Now you know that we have our stone list here. On this we can call a get method, and from the get method we can get we can pass our index of largest, this one. So we'll get our largest value, you can say, right. So I can give this name as result, and we are returning our result. But one more thing we have to do is what, now we know that the we got our what we can say result, right, largest element we will get. But one more thing we have to do, we have our stone, right, stone list. So on the stone list we have to set its index. Set, see, two argument 1, argument 2 we have to pass, right. So first argument we will pass is index of largest is as at this. What we have to do, we have to update the stone list dot get, and this get will take what, two thing, what we can say, no, one thing will take that is a stone dot get, and it will the last size, you can say, right. We can say we have to actually do stone list dot, we can do to size like this, right, and we'll do minus 1, right, for the last element. Okay, so from the size minus 1 we'll get last element, right, and we'll updating its index. Okay, now this is done. Now what we have to do now, from the stone, right, from the stone list we have to do what, one remove, and we have to remove what, the last element, right, because the stone list we have. From here we'll do size, we know that we'll do size. On this size we'll do what, minus 1. Last index we have to remove from the stone list. Okay, I think this would work. So what I'll do, let me zoom out. Okay, this is good. Okay, now I'll do run. Let me submit. Oh, good. Give me 1 second. Now understand about this one. Okay, why this is more important? See, we have to understand now the complexity. Okay, we'll understand the complexity. So we have given what we have given, what we have taken. We have given a stone list, right? So if the stone list, no, the size of a stone is n. Okay, the size of a stone is n. Okay, we have the length of stones is n, we can say. So here on Leetcode we are testing our code, right? How we are checking n is less than equal to 30, right? You can say. So in an interview, through be very careful about such assumption. Actually, it is very likely your interview experts you to come up with the best possible algorithm, right? So you could thus handling the higher possible values of n. So what you can say, the time complexity will become what? O of n square, right? O of n square. Why? Because the only O of 1 method is to find the max. This will take to find the max here, as you can see. Where is that? This one. It will take find of this one is taking what? O of 1. The only non O of 1 is the stored array, that is the find max. This method does a single pass over the array to find the index of maximum value. So this pass has a cost of what? O of n, as you can see, right? And once we find the maximum value, we delete it, right? After finding this, we are deleting also. So although this is only has a cost of O of 1 after deleting, right? So because instead of shuffling along, we simply swapping with the end, right? We are doing. So each time around the main loop, there is a net loss of either 1 or 2 stone, right? So starting with we are doing, right? Here we are doing, okay, we are losing 1 or 2. So each time neither we lost 1 or 2 stone, right? Starting with n stone, so we go to 1 stone, right? This is up to, you can say, if there is n stone, so we'll go to what? n minus 1 loop we are doing here actually at this position, okay? And to understand this one, right, for each iteration, right, this iteration it will do find the maximum of twice, right, doing the same thing. That's why it is taking O of n square. We are doing the twice actually, right, for one stone or a 2 stone, right? We are doing. Now note what we had to do actually. If we had shuffled instead of swapping, right, at the end using this method, right? If we are getting the find this one and then we are doing, right? So this method will take O of n as we pass and then we'll delete one after the other. However, it is a best to avoid the larger constant, okay? So we can say simply O of n square will take the time complexity, and if we'll talk about the space complexity, O of n or O of 1, right? How? Because if we are using Java, right, this will take just O of 1, right? But the same concept if you implement into Python, it will take O of 1, right? So we need to convert into, you can say, integer to array, integer to int to integer, and it is possible to write O of 1 space solution for Java, right? So I'll say O of 1 will take a space complexity, and this is your time complexity. And if you want to know how to do the implementation using the you can say heap or you can say priority queue, please let me in the comment box. So I'll create another part of video, right? I'll do that, okay? Thank you for watching this video, guys, and stay tuned with our expert funda.